Hello, everybody. Good morning, good afternoon, wherever you're at. Today we have Raul Chouza. He's going to be talking about contract programming with Elixir. I'm excited about this one. So I'm happy to moderate it as well. Raul is a computer engineer, eventually turned into a web programmer and programming languages enthusiast. His current hobby is collecting books and obscure board games. I am going to turn it over to Raul, but if you guys think of any questions during the presentation, please use the Q&A section. And towards the end, if we have some time, I'd love to call you up to read some of those questions for Raul. So I'll ask for your video to be turned on and your microphone unmuted, video if you want, and you can ask Raul. So with that, I will turn it over to Raul.
Thank you so much, Jamie. So I'm so happy that everyone made it to this talk. I really hope that you like it and that we are able to spread some interesting discussion around it. So the title of this talk has zero spark. It's just contract programming with Elixir. So contracts, like we often hear this word in software, but what do we mean by it? It usually depends on the context or the conversation. So let's explore more this concept in Elixir. We can definitely say that our logic or implementation is a form of contract. By explicitly defining imperative instructions, we are building a behavior inside of our function. Our code is by itself a specification. Another take on contracts could be that.
Raul,
yeah.
I'm sorry. You're not showing your screen. You can share your screen.
So
I'm sorry about that. Yeah. We had this discussion earlier. Should we start with the screen or not? We should have.
Yeah. I totally forgot.
That. Yeah,
so
no worries.
We'll remove it from the show, right?
We'll fix it in post.
Yeah. So, okay, I will start over. So glad that everyone made it. This is contract programming with Elixir. And well, as I said earlier, this talk has zero spark. It's just contract programming with Elixir. So let's just start. So what are contracts? We often hear this word in software, but what do we mean by it? Like it usually depends on the context or the conversation. So let's explore this concept in Elixir. We can definitely say that our logic or implementation is a form of contract. By explicitly defining imperative instructions inside our functions, we are building a behavior. So our code is by itself a specification. Another take will be that contracts are just patterns. What shape does our function accept? Elixir lets us do pattern matching on a variety of contexts with guards, lambdas, cases, with clauses, rescue clauses. This language feature, I think, is one of our core strengths for beautiful, easy to read code. Another kind of contract can be found at compile time with behaviors and protocols. Behaviors which are about implementing parallel interfaces which later might be plugged in and plugged out of different contexts. And protocols which are about applying a common interface to yet to be known data structures. We can even say that no, our contracts are kept inside our tests. Implementation are just details, and what really matters is ensuring that our input and output is done along the given specification. Or we could go further and add tools like Elixir or Elixir, which enforce specifications between you and your code. Or tools like Credo and the formatter, which are between you and your team. But for this specific talk, I mean contracts in the design by contract sense, or just contract programming. One of the languages that implements this concept natively is IFO. Here is some IFO code. It's a balance class which uses contracts to make deposits. And if we pay attention to the middle, to the deposit function, we will notice the require and the ensure clauses. The require contract runs before our implementation, while the ensure contract runs after it. If any of these clauses fails, the program just crashes. And given that for this specific class, we are operating on money, crashing is probably more desirable than returning a bad result. This mechanism lets the programmer define properties about the domain subject. Because of this, IFU was sometimes referred to as a design language. And while these concepts go way back in history, IFU was probably the first language to fully go into contract-based programming, with lots of features like testing and documentation powered and augmented by contracts. It also sprawled a very flavorful glossary of concepts. We can go into this rabbit hole, but backtracking a little, this is not meant to be a talk about IFU. Neither of these languages that also do contracts or something similar to contracts. This is an Elixir talk, and Elixir is a language for the concurrent world. We do have processes. We just let it crash. But still, we can benefit from contracts. But how? Let's go through some basics. One of the most basic forms of a contract is that of an assertion. Assertion as in the asserts keyword in XUnit. Predicates are really nice to assert, so we will go along with those. By asserting the predicate, we will either pass the test and let everything be alright with our code, or fail the assertion and generate an effect, like raising an error, throwing an exception, or maybe a tag at OK error tuple. The point here is that the program failed, and therefore our program is worried. And then, by composing a series of assertions, we can get nice guarantees about our programs. So for example, here we are passing a piece of text through these assertions, and we are checking that the text is a binary, and that the text has a length between 0 and 10. Putting this to the test, if we pass the word program, this will pass. But if we pass the word programming, this will fail, because programming has a length greater than 10. In Elixir, we do not have an asserts keyword included in the standard library. But we do have a match operator, which can be considered a type of assertion. We also have the asserts macro found in XUnit, which combines predicates and matches. Thankfully, it is quite simple to improvise an assert function. We just need to match on true or on false. So for example, here we have our asserts function. We do pass a value and a predicate. Then we operate the value on the predicate, and if this expression evaluates to true, we just do nothing. Here we just pass the initial value. But if it evaluates to false, here we will raise an error. And here we are using our totally not made up function to prove a point. The important here is that we are using contracts before our implementation starts, between our implementation, and after our implementation to keep some guarantees in our function. And we can now test this function that only accepts the specified inputs. So for example, an empty input to this function will fail because the string cannot be empty. If we pass something that is not a string, it also fails because the parent must be a string. And if we pass a piece of text, we actually return something because we are abiding. We confirm that our output abides by our specification. And if we pattern match each chunk of code, we could even name them by calling the first chunk our preconditions, the one in the middle are our invariants, and finally ending with our post conditions. And with this, we just created a contract mini framework. And let's just remember, in Elixir, we do not have contracts in the sense that we don't have an asserts keyword. but we do have macros, along with incredible libraries. So let's do some contract programming. We are going to do an URL shortener. Hopefully this will shine some light on how contract programming can or not help us do software. The requirements are simple. We put in a long URL and we spit out a short URL. So let's see a preview of how that looks at this web page. So here we do have like a URL minimizer. So let's try some URLs and see how that works. If we type example.com, we get this URL back. And if we click this URL, we are redirected to example.com. And for example, we could try a larger URL like this Wikipedia one, shorten it, and here we do have it. And it is all working. This is really nice. So let's go and do some live coding. Let me switch my screen. So, okay. So here we have the basic implementation. I started with the project already, and I already have a couple of functions. The first one is our API, which is shorter URL, where we pass a URL. And here, basically what's happening is we are generating an ID, and we are concatenating with this prefix domain. And then with this, we're generating our short URL. And finally, we are just storing it in a key value store where we put the short URL along the longer URL. So we can retrieve these values later. So let's try out this code in IEX. So if we try our shorten URL function and pass in, like, for example, example.com, we are getting our shorter URL. And we can do this many times. And then we can check our store to see the current state of our store. And then we can see how the short URLs are paired up with the longer URLs. And before we go any further with this, like this looks good enough, but before we go any further with this, let's add some documentation and specification. And let's do some magic to go forward in time. And here we just added our documentation. In our documentation for the module, we put in the requirements that we want, like we should accept a long URL and should return a shorter URL. And then here we also document our functions and put some specs in our functions. And let's check, we also have some tests. So let's check the tests. The tests are really simple. Like we have a long URL, we pass it through the short URL, and the asserts only checks that the longer URL is actually longer than the shorter URL we are generating. So if we quickly test this code, we see that we have one test passing. So excellent. Let's go back to our presentation. There. Okay. So can you see the presentation? Sorry. Oh, there. Okay. So let's explain this function a little bit. As pure as we want, so this is a function we implemented, and some thoughts about this is that as pure as we want our domain model to be, Elixir is blooming with side effects. With just a couple of lines in, we are already generating random strings and storing into memory the results. And granted, we just did one test, but there's a lot more to test for. Especially with the way we are storing the data, there is no uniqueness in our data store. On restart, we lose everything because everything is stored in memory. We are using a neat table. The URL generation is iffy because of how we are generating the ID. And our URL models are definitely not perfect. They are hard-coded into the code. And testing all of these will be super useful to guarantee that our software is okay. But for this demo, I will just pretend that this is just fine. So if this is the case, how then can we benefit from contracts? Let's have a look again at our requirements. We might be missing certain guarantees. So the first one is that we are not checking that we are receiving a URL and not any other kind of string. We are also not checking that we are delivering the right shorter URL. And we could use contracts to guide us while we develop. We are going to assert, for example, that here we are receiving a valid URL, that the result has this shape, and finally assert that our initial URL is actually longer than the resulting URL in length. So let's go and do some contracts. So let me share my code again. There it is. And let's go forward in time again. Perfect. So what happened now is that we added the X contract library to our dependencies. And now we are ready to put some contracts into our shorter URL function. For validating this, it will be very nice to have a predicate helper which checks a URL. So we already have that, like right here. So here, if we pass a piece of text, we are going to return true or false, depending if it's a valid URL or if it's not a valid URL. We also do have some tests for this URL predicate. So if we pass something that looks like a URL, we return true. But if we pass something that is not an actual URL, we return false. If we do the test again, we now have a little bit of more coverage. So let's return to our code and see how we can translate the defined contracts we had in the presentation to actual contracts that X contract gave us. So for example, for checking that the receive parameter is actually a URL, we can do this. We say requires, and we pass our predicate URL. And if this check fails, we return this error. This error will be raised. Given the string should be a valid URL. And we are also going to match on our prefix. So for example, we also make sure that when this function returns, it matches with this string. So we are going to do some small changes here. The prefix, let's move it to a constant. So we are matching right here with the string. And if this fails, we return the error, given the string should match the prefix. And finally, let's ensure that the length of the function we are returning is actually shorter. So here we have our ensure function, and we can just start to test this function. So, oh, I forgot to add the prefix right here. And let's try our functions again with IEX. And for example, if we try example.com again, it actually doesn't pass a condition. And what is happening here is that example.com is not shorter than the URL we are actually generating. Okay, so let's see what happens if we pass a longer URL. This URL, of course, doesn't exist. It actually passes, but we noticed an error because we passed the example.com URL. So it turns out that our hard-coded mini.mix domain that we have here is actually not that short. Example.com is shorter, therefore we are not complying to our contract. So what do our tests say about this? We haven't changed our tests, so everything is passing. So what we could do is add another clause to our tests. Here we should not only be checking this URL, we can be checking also example.com. We save, we run our test again, and this case is now failing because we are actually not complying with this assertion. And now we can clearly see in the failure, there seems to be something wrong somewhere, either in our code, in our tests, or in our contracts. So let's go back to the whiteboard and try to come up with something that works. So we go back to the presentation, and okay, let's go back to the whiteboard. Maybe we can always make our URLs shorter, but we should not torture ourselves with bad requirements. Clearly, this is not the shortest URL available, and this domain is already quite expensive. Spoiler alert, this domain doesn't exist. So let's change our requirements, therefore our contracts. Getting rid of this class will solve the issue. But there's the other problem. This issue only came to light when we tested for example.com. We are still testing with 2 URLs, and I'm pretty sure the internet is a big place. Thankfully, we have an ally by our side, property-based testing. And with this technique, we will be able to generate lots of hopefully good URLs that will be kind of annoying to type by hand. And I don't want to bore you too much into the detail, so let's watch some videos. We will start by installing the stream data dependency. This dependency already ships with some macros and some helpers to build property tests. Then define a model to generate the URLs along the stream data type. So let's see this in action. So in this video, we are going to first create a generator. So we will define a generator module. I will just copy and paste some code. So this is not necessarily a good example of a URL model generator, but this will serve our purposes fine. And let's try some examples of how this looks. So if we try minimix.generator.url, we are going to return a stream data type. And then we can use it along the enum module to take in either 10 generated URLs or 50 generated URLs or 100 generated URLs. Also, aside from the generators, stream data gives us nice testing primitives for checking our models against our domain. So first, we will declare our tests and check that we will generate a new property test module. And here we already have a template for that. And check that our model and our predicate URL work well together, because otherwise it will not make a lot of sense. So first we want to check that our URLs make sense, at least for our context. So we will use the check all macro, which will generate URLs from the generator we made, and then asserts that all of these generated URLs are actually URLs that we can interpret. And if we run the tests, we will see that everything is passing. And just to shine some light into this, let's print what is happening with all the generated URLs and run the test again. And we are generating a ton of URLs, and everyone is passing the URL, the URL predicate. So let's copy this code and modify it so it works with the shorter URL function. And here, what we really need to do is to just run the shorter URL function. We test again. And here, I want to stop the video and see the failure. So what is happening is that we never change our clause that checks that the URL is longer than the other. So we are getting the same error as before. The generator is generating this short URL a.ac/a, but our our prefix minimix.url mini.mix domain is actually larger than the generated URL. Therefore, everything is failing. So before going on further, we definitely need to change that requirement and to change that contract. But before going further, there is this question is there a point of doing contracts when we already have assertions and property-based testing? Let's see a quick experiment. We are going to exchange all of our contracts with assertions in the property-based test. So we'll just grab these contracts and change them so they become assertions for XUnit. So here we are going to receive a result from our shorter URL function. We are going to remove the errors from the contracts. And finally, we need to change our prefix so that we're just going to hardcode it. And with this, we can run our tests again. And we see kind of like a different error, but it's also very similar. Semantically, it's talking about the same. And it's that our generated URL is actually shorter than the prefix we are using. And here, instead of raising the error, it's just raising the error, but on the assertion. So it says that the left side is only 14, while the right side is 22, and 14 is not greater than 22. So this doesn't make a lot of sense for XUnit. So semantically, it is the same that we had before. So contracts and property tests are interchangeable. Yes, they definitely are. Then, does this make contracts obsolete? Something to keep in mind here is that we didn't need to create generators or use a property test framework before we use contracts. We just needed to declare the contracts in our functions, and just by using it constantly on IEX or while we were developing, we were able to come with some inconsistencies of our requirements. So I'm not saying that we should not use property-based testing. We should definitely use it, but contracts can work very well by themselves. So the URLs we are generating. Oh, okay. Sorry. So we are going to return to the example. I think we corrected our contract. We already changed that, and everything is working as expected. So let's go ahead and start generating some URLs to show off to our clients that asked for this functionality in the system. And let's see what is happening. We are generating these URLs, and if we go here to the secret vector, we are going to see the stored URLs in our database. And the feedback we get from our clients is that these generated URLs are not actually very secure. And not secure in the sense of security, but in the sense of these URLs do not have a lot of meaning by themselves. So how can we be sure that if we click this URL, we are actually redirecting to Wikipedia or to example.com? We don't have that guarantee. So after failing to impress us or sponsors, we come back to the whiteboard again. And the initial requirement of make a URL shorter really lacked a lot of nuance to it. And this is a reality of a lot of the software development being done around business domains. Everything changed. Requirements are ever hardly set in stone. Thankfully for us, this gives us the opportunity to be creative with a solution. So instead of creating only a URL shortener, we are going to create a contextual URL shortener. What does this mean? Let's just decompose the idea a bit. So we are going to extract the parts that gives meaning to the URL, being the URL domain and the path. And for the URL domain, we just want to remove some artifacts like www. And for the path, we might want to do some branching depending on the string. If it's of length 5 or less, we keep it as it is. If it's of length between 5 and 10, we remove the vowels. And if it's larger than that, we just ignore it. So this, in the end, will give us a URL like this. And the URL is not actually shorter. We already given up on that, but it can be shorter, which is a little bit different. So let's see a quick demo of this. And again, we will go forward in time, just to not waste too much time. And we will see what changed. So here we already implemented our contextual shorter URL, and I think I'm not in the right place. Perfect. Now we are on the right place. So here we just created our contextual shorter URL, which does some magic with the domain. But what I wanted to show about this function is how we are dealing with the path shrinking. So here below, what we are doing is that we are splitting the path in different segments and then joining it. But between that, we are shortening the segment. And here we are taking advantage of pattern matching to actually decide what to do with each segment. So if the segment is less or equals than 5, we just pass it in as it is. If it's between 5 and 10, we replace the vowels. And if it's larger than 10, well, we do nothing. We return an empty string. After this, if we need to replace the vowels, we just do that, and we just use string replace word with vowels and replace them with an empty string. So just to run a short demo of how this works. We'll use the contextual shorter URL, and let me copy and paste the longer URL. This one will serve well. So here we are passing in this URL, which is not very large, but here we can see that we are already doing some magic with the strings. So with this, I will just go forward in time again. And what I want to show off here is that we are adding some contracts. So here we already added some contracts. I will just want to highlight these contracts. So requires and ensures. So here we are highlighting all the contracts that are relevant for all of these functions. So first, for our API, for the contextual shorter URL, we are highlighting that we require a URL and then that we are matching with the desired prefix as the one we had before. For the shorter URL path, here, because we are actually shortening the path, we can make sure that the initial path is always larger or equals to the result. And finally, when we replace the vowels, we can create contracts to actually say that, hey, are we checking that we are actually replacing all the vowels? So we also made some property tests, which were quite easy to do. So let's do just that. So for example, here we do have our property-based test for the contextual shorter URL. It doesn't change anything. We are just running the same generator and we are running the contextual shorter URL function. So if we run this, all our property tests are passing. So with this, let's go back to the presentation. With all this, I think we are pretty well equipped for a second round. And this is the end of the exercise, but just a couple of thoughts before ending the presentation. So there might be occasions where you might want to handle errors, and there's no secret formula for when or how you should do this. At least for our purposes, a good way of handling errors with failing contracts might be something like this. We are just rescuing the function from the error. And by doing this, we can tag it, or we can handle it whatever way we want it. So for example, here in our application, we are actually doing that to manage wrong URLs. So what is a wrong URL? Something like this. And if we try to shorten it, we can't. And here we're able to minimize it. So, I mean, there are many approaches. We might use contracts to handle errors, but this is not the only way of doing it. It's completely valid to just manage all this logic completely separate. So we can have like the contracts on our backend, and then on the front end, we can have other functions that actually do the validation and then return the desired error messages. But whatever strategy you want to follow, I think it's valid. You might want to use changes, you might want to validate your functions manually, you can use whatever handling technique you feel comfortable using. Another consideration is that not all contract libraries are created equal. Sometimes contracts are meant to be used only during development context while we are building our app, using IEX, or just doing testing. But then they are deactivated in production for performance reasons. Sometimes you might want to keep contract guarantees at production if your process is critical and not necessarily time critical. So contracts are specifications. Some conclusions just to end. Contracts are specifications, and these enforce correctness at the internals of our systems. This by itself doesn't necessarily make our software better, because we can still derive specifications from the wrong requirements, from the wrong idea. But having specifications declared somewhere might give us the security that we are on the right path. The tool and technique we use might vary. It can be testing in all its different forms. It can be contracts or assertions. It can be types. It can be solvers, diagrams, or just a piece of paper. So this is not about perfection, but about achieving our objectives. The requirements will always be subjective, but I think contracts can lead us into specifications that are not entirely rigid. So we might keep subjectivity in our domains without this subjectivity becoming something we cannot control. And with that, I want to end the talk and give some thank yous. So thanks everyone for watching. I would like to thank the next individuals and groups. First of all, the Erlang and Elixir Denver meetup group, which went through a very rough first draft of this talk. The Virtual Beam meetup, which went for the lighting version of this talk. Hugh Wayne for discussion on testing and contract definitions. Jeffrey Matthias for his perspective on tests and contracts, and many other individuals that I am not given enough credit for. If you feel like you belong here, please reach out. Also, my peers at Erlang Solutions for all the kind feedback on this talk. And one note, Erlang Solutions is hiring. We have teams in London, Stockholm, Krakow, Budapest, and I just joined the Americas team. I'm pretty excited about that. We are completely remote, and if you feel like this will be an opportunity you would like, don't be shy, check out the Huoba postings or just reach out. And thank you everyone for being here. So finally, contracts. What do they mean to Elixir? Do they let us write better specifications, better tests, or is this just unnecessary noise? I would like to stop talking and just open discussion for questions or just share up your opinions.